All right, this is section 6.2, page 5. And we're going to summarize all the formulas that we have to make it easier so that you can notice what's going on. So we're going to start off with the location of the vertex is in the center. This is the one we started with. So this was the central angle. Okay. And if we call this A and B, let's talk about what the formula is. So the measure of angle P is equal to what? Well, we know that the angle is equal to the measure of its intercepted arc if the vertex is on the center. So this is just like this. That's our easiest one. Notice no 1/2 in that problem, in that one. Okay, if it's in the interior. So now we're going to talk about the two lines intersect in the interior, not on the center. So let's do a line like this, let's say, and we'll do a line like, I don't know, I'm trying to avoid the P here. So we'll just say like that. Okay, so we'll call these, we have to call all these things something. So why don't we do, we'll say here, this is A, okay, and this is, I don't know, let's go around the circle. B, this is C, this is D, and where they intersect is O, okay? So notice that the vertex of any one of these angles that we created here is in the interior. So if we wanted the measure of angle, let's say BOC, what would that be equal to? Well, its vertex is in the interior. So here we say it's 1/2 the measure or the sum of the measures of the intercepted arcs. So what are the intercepted arcs? Well, we have this one here. Okay, let's kind of label them. This one here, okay, and this one here. Those are the intercepted arcs. All right, so AD plus BC. All right, now, if we're on, the vertex is on the circle, okay? So let's do it like this. And we'll call this A and this B and this C. Okay? So if we're on the measure of angle ABC, what is it equal? Well, if you remember, it's 1/2 of its intercepted arc. So what's its intercepted arc? Goes between the two rays. Okay, so here this was the intercepted arc. I could have drawn that one as well. Okay, 1/2 of its intercepted arc, which would be the measure of arc AC. Okay, then finally on the exterior. So it really doesn't matter if we have tangents or we have secants. We're going to do one of each just so that you can see what's going on. So we're going to say A, B, C, D. Okay, so here we're going to say the measure of angle, I don't know, we'll say BCD. Okay, where is its vertex? On the exterior. So remember, this is 1/2, and then we're subtracting the arcs. So let's take a look at what the arcs would be. Well, it's going to be this big guy here, right? Look here. What are the intercepted arcs? This one here. Okay, so I need another point on this so that I know which one I'm talking about here. So let's go ahead and call this, let's see, E. Okay, so we would say this big arc, which is AED, okay, and then subtract the smaller arc, which is this one here, BD. Yeah, I don't like that. Let's make it a different color. Okay, all right, so BD. Okay, now I want you to kind of step back and take a look at what's going on and understand it. So notice that here, this is our biggest angle, right? As we're drawing these angles, look what happens as we make the vertex move through the circle. Here's our largest angle. As we move the vertex back a little bit, what happens to the angles? Okay, they keep getting smaller and smaller. Look at this opening. You know, it's open big like this, and then you're pulling it back and back and back. What? I don't know if you can see that. You're open big, then as you're pulling it back, it happens like that. If the rays of the angle have to stretch further, then the openings are getting smaller. So you notice what's happening there. That as you pull it back, the angle gets smaller and smaller. Well, that's why in the beginning here, you just have the intercepted arc. As you pull it back a little bit, you say, well, it's the average of these two arcs, which is what you're talking about. And then here, it's just, so you're adding. So you're going to get more than if you just take the one, okay? And then when you pull it all the way outside here, you can't even add anymore. You have to subtract to make it smaller. So hopefully you're seeing when you look at this angle and you look at this angle, that it's being pulled back and the actual angle gets smaller. So notice that as you're doing your problems. Okay, now when we do number 12 here, this will put it all together for us. So we're told that the measure of angle 3 is equal to 42. So this is 42 degrees. Okay, and then we're supposed to find the measure of arc RT, so they want to know RT. Okay, that's one thing they want to know. And they want to know RST, so around this way too. Okay, so we're supposed to find both of those things, and we don't know either one of them right now. Okay, so why don't we go ahead, since we don't know either one, and call one of them X. Okay, so if this one is X, what would this one, this yellow one, have to be? Well, all the way around there, what? It have to be 360 degrees all the way around. So if we take away X, what are we left with? 360 minus X. Okay, so that's what the other arc is going to be. So that's the hardest part of this, is thinking about that's how we're going to go about doing it. So to figure this out, we know this angle. We know the angle 3. So angle 3 has its vertex outside the circle. Okay, so we know how to write a formula for that. We know that the measure of angle 3 would equal 1/2, subtract the two arcs. So we're going to say the measure of the first big arc, 360 minus X, or no, just call it RST. Okay, minus the smaller one, RT. Okay, that's what the formula says to do. When the vertex is on the outside, you take the big arc minus the small arc. All right, now we know that measure of angle 3 is 42 degrees. So let's put that in. Make sure you're able to see that. Yes. Okay, and then 1/2 what? Well, we know the measure of angle RST, or arc RST, is equal to 360 minus X. And I'm going to leave the degree signs out. Okay, so that's this part right here. Okay, and then minus, so that's this sign right here. What is arc RT? Well, X. So that's this one here. All right, so what do we have? We have, let's move over here, 40, I don't need to be down so far there, 42 degrees. 42 equals, let's leave the degree sign off, 1/2, and then we have 360 minus 2X. Okay, we have a choice. We can distribute through the 1/2, or we can multiply both sides by 2. So this time I'll just go ahead and distribute by 1/2 to be different. Okay, so we have 42 equals 1/2 times 360, that's 180, minus 1/2 times 2X is just X. Okay, then to solve here, I'm going to subtract 180 from both sides. And what do I get? I get negative X equals negative 138. Or divide both sides by -1. I get that X equals 138. Okay, so what do we just find? We just found that x is 138, or this arc here measures 138 degrees. So we know that then the measure of arc RT, since it equals x, it has to be 138 degrees. Oops, little sign, not a big one there. Oops, I'm out of my whiteout. Okay, well, we'll just have to make that part of our circle there. Okay? All right, so now part B. What are we going to do for part B? We need the measure of arc RST. Well, that's pretty easy to do now that we know that what the value is. It is equal to 360 minus x. So we put in the 138, and what do we get there? We're going to get 2 and 2 and 2, right? When we add that 0, 0, yep. 222 is our answer. So that's the answer there. All right, that concludes page 5. Go on to page 6.